ADAPT-ABI 2009, Bridge Design Accelerated. ABI 2009 contains several new features for a more powerful and efficient modeling experience of concrete bridge structures. These include a 3D modeling environment with construction staging and the analysis of incremental long-term effects. A section manager allows you to define and manage user-defined and predefined bridge segments. The expandable moving load library comes with predefined load trains and user-defined load trains. New building codes such as ACI 209, the Indian Code, Eurocode, and AASHTO 2007 are included in the program. The purpose of this tutorial is to show the modeling of a 3-span continuous bridge in ADAPT-ABI 2009. To begin the process, we're going to import a drawing file. This drawing file will contain the section geometry and also the basic bridge geometry for easier layout. If I select the XZ plane for the current view and say OK, the program will ask us if we want to calibrate the project. We'll say yes, and we'll select two known points. If I turn Snap to Endpoint, click on one end of a grid line and the other, and in the yellow bar below we're going to say 250 feet. We'll say no for the project origin. We can now take these sections, which are closed polygons, and we can transform these into geometrical sections that the program can use for defining segments and also piers in the model. I'm going to select all of the segments, and I'm going to use this Transform Selected Polygons into Sections tool. It will ask if I want to calibrate. I'll say yes, and again I'll select two known points. This is 12 feet, so I'll enter 12 feet here and say Enter, and 6 sections are then created. To review these sections, we can open up the Section Manager. Here you can see that 6 user-defined sections have been created. I also have 2 sections that are created prior to the beginning of the model. These 2 sections will be used for tapered sections over the bridge piers. We're going to go ahead and rename these sections. And finally the deck segment. Once the sections have been labeled, we can say OK. Those are the sections that will be used for creating the model. Notice also that the bridge geometry is included in the drawing file that was imported. We have an end segment of 200 feet, both ends, an interior segment of 250 feet. We also show the dimensions for the closure splices, the beginning of the pier haunches, and also the intermediate spans between the closure splices for the drop-in segments. This makes it easier in creating segments along the length of the bridge. The 2 pier lines or pier center lines are here, and the piers will be 50 feet from the top of deck. Prior to beginning modeling of the pier and also the deck sections, we're going to go ahead and validate the material for concrete, pre-stressing, and mild steel. We're going to leave the default values alone for the different mechanical properties and creep and shrinkage values. We're going to select the AASHTO 2007 code using the default values. The user can also modify the default values here. And for the mechanical properties of the concrete, we'll use 4,000 psi concrete And again, we'll leave these values alone. The same can be said for pre-stressing. And for the mild steel, we're going to set the minimum reinforcement ratio to 0. This will make sure that no reinforcement is being included in the bridge sections. And say OK. Now that all of the sections have been created, we can begin modeling the bridge by creating segments for the flat work and also vertical sections for the piers. This line will represent a reference line. We need to transform this regular line into a reference line using a transformation tool. That's located here. Or you can simply draw or add a new reference line with this tool. Once the reference line has been created, we can begin creating segments along that line that will represent the different segments of the bridge. To do this, we need to go to a developed view. Within the developed view, we can begin to add segments using this tool. Using Snap to Intersection, I can create these small segments. Each separate segment is going to contain a different section type. That's why I cannot create a section along the entire length of the span or each span. So I'm breaking this up into multiple segments between these reference lines that I've created. Once that's complete, we can say exit. And if you see here, each of these segments is the same type of section. If I was to double click on a section or a segment, under the section tab, you notice that this is pier top deep and pier top deep for the beginning and the ending section. So for that particular section, we want to change that to the drop-in segment. For each end, we'll say drop-in. And graphically, that changes to the proper section. One other thing to notice is that there's a pier diaphragm that will be placed here at each pier, but these segments go to the center line of the pier. So we're going to modify those once we've gone and changed all of the different segments. Beginning at the end, this will be an end block or a splice. The next segment will be the drop-in segment again. Now we get to a closure splice. The left side of the pier has a haunched or a tapered segment, so the beginning is going to be the shallow pier top. The end will be the deep pier top. And then the opposite will occur at the other side of the pier. And we'll continue on with this, finishing the different segments. The segments have all been changed to the proper type of section. And now we're going to go ahead and add the pier diaphragms. The first thing we'll do is we'll click on the left side, and at location, we want to do an endpoint offset at the endpoint. This is going to be negative 12 inches. We'll do the same for the opposite side at the starting, which will be 12 inches. Now we can go ahead and add a new segment. To change the segment type, we can go to the item properties. We can go to section. This is going to be a pier diaphragm. And then we'll just click on both ends of the segment. Using the Snap to Intersection and Snap to Vertices tool, we can click on the first end and the end point. We'll do the same on the opposite side. We can now see that there are pier diaphragms at each pier. So now we can go ahead and actually define the pier. To do that, we're going to add a pier, which is here. And we can just click at any location on this grid line. So I'm going to click there. Notice that the pier is added below the reference line at the bottom of the haunched segments. I'll do that on both sides. And I want to define those as the pier section. So we'll say pier. And now we want to make this 50 feet in height. So under location, we can modify the Z coordinate, and this will become 27.64. We'll press the green check mark to accept, and we can do the same on the opposite side. And now our piers have been defined. The last thing we'll do is add the deck section. To define the deck section, we need to add a new segment in the model. So we'll click Add Segment, and we're going to click at the beginning and end point of the spans. Notice that the deck section was placed below the reference line. So now we need to shift that section so that it's above the reference line because the girders and other elements begin at the reference line. So we want to grab the deck and double click. At location, for a Z offset, we want to say 6 inches at the start and the end points. Press the green check mark to accept, and now the deck was shifted above the reference line. Once the geometry, the sections, have been input, we can go ahead and turn off this imported layer. We can go to Layer Settings, scroll to Default, and turn that off, and we're left now with the bridge geometry. The next step will be to add supports and define any loads on the bridge during construction. For this particular model, we're going to define a dead load of 500 pounds per foot, which will represent a barrier load on this girder. To begin, we want to add the supports at the base of the piers, at the temporary locations, for example on both ends of the drop segments and ends of the haunch segments over the piers, and also at the abutments. To add a support, we'll go back to Developed View, and we're going to use the Add Support tool. The default support is a hinge support. We'll begin creating those by placing them at the piers and also at the drop-in segments. These supports will represent any false work or shoring needed during construction. And finally, the left side abutment. To change the symbolic size of the supports, we can go to the Select Set View Items, and at Supports, we're going to go ahead and change the symbol size to 15 inches. That allows us to grab the supports easier when we go to modify and when we go to install them. The next thing we'll do is we'll create a load. To create a load, we need to define a load case. Under Loading, Add Load, we can add a line load, a point load, self-weight, or temperature load. If we go to the load case library, we're going to call this dead load, and we're going to add. We're going to also delete the default load case that's assigned in the program. Once that's been added, we can say OK. Notice that the dead load name cannot be used, so we need to change the name. We'll just say dead and say add, and again we'll delete the defaulted load case. To add the load, we'll go back to Loading, Add Load, Line Load. We're going to click the full length of the bridge. If I then double click on the load, we can add a magnitude to the load. We're going to select dead, and FZ1 will be 0.500 kips per foot in the negative direction. And now you see we have a load added to the structure. If we double click on the load, we can edit the load in the editing box for the line load. To turn off the load in the view, we go back to Select Set View Items, and notice that line load is not selected, so we'll just say OK, and we'll go back to the default view prior to adding the line load. At this point, we also want to add the self-weight. We can add the self-weight in two different ways. We can go to Loading, Add Load, Self-weight, or we can use the loading toolbar here where we want to add the self-weight. The multiplier is -1. We'll say OK, and now the self-weight has been added for step 0. Once the gravity loads have been added, we can now assign moving loads to the structure. To do this, we need to add a travel path. The travel path will be the full length of the bridge at the start point and to the end point. Once the travel path has been assigned, we can review the moving load library for the load trains that would apply to the structure. We can add new load libraries, or we can also modify any existing load train. For this model, we'll use ABI Uniform and HS 2014. Under Moving Load, we'll now define the load cases. We're going to add 2 load cases. The first case will be the ABI Uniform, the travel path. We'll deselect Max for Sign and select Forward. The second load case will be the HS 2014 truck, and we'll leave the settings here as they are. Once the load cases have been added, we can review the load combinations. Under Loading, Load Combinations, we can see that the program contains several default combinations. It also will include the different load cases that were assigned to the structure. This is the dead load case that was assigned as the barrier load. And down lower, we can see that these are the 2 moving load cases that were just assigned. We now want to create a load combination with the dead load and also the 2 moving load cases. So here we'll set a factor of 1 and also 1 for case 1. We'll say Create Load Combination, and it's populated down below. And now we're going to do the same for case 2 of the moving load. And now we can see that that's also added to the list. We can also do an envelope of combinations. So if I say 1 for this combination and also one for that combination, we can create an envelope. I'll say OK. The moving loads have now been added to the structure. We're now going to add the tendons to the bridge. To add the tendons, we'll go to Developed View, use the Add Tendon tool, and we're going to select the ends and also the points above the supports. To select this point, we need to turn on the Snap to Midpoint and also the Snap to Vertices, and we can select the midpoint above the support. We'll go ahead and turn those tools off now. And we'll snap to the right endpoint. We can see here that a warning appears saying that the tendon is outside of a cell. That's fine, we'll just say OK and exit. We're now going to modify the CGS of the tendon such that it's inside of the structure. So if we double click the tendon, the area is going to be 0.153. The tendon diameter will be 4 inches. We'll select 16 strands. For stressing, nothing's been stressed, so there is no stress history. And if we go to Shape, System, and Friction, span 1 is going to be a simple parabola with the inflection point being at 0.4. Span 3 is also going to be a simple parabola. And span 2 will be a reverse parabola. The CGS points for this particular bridge will be 31 inches at the end, 27.5 inches at the midpoint, and at the supports we'll use 13.5 inches. Again, we'll use 27.5 at the midpoint and 13.5. And at the end will be 31 inches. We'll press the green check to accept those changes. And now the tendon is located within the bridge. For demonstration purposes, we're only going to use one tendon with 16 strands for this model. Once the tendons have been added, we can begin to add the different stages of construction for the model. To do this, we'll go here to the project browser, and we're going to add several different days. We'll add day 7, day 14, day 21, day 28, day 35, and we'll add 2 additional days just to extract results, mainly for the effect of long-term creep and shrinkage. Once the days have been added, we're going to select Output All. This will give us output for each different stage. We can rename each step. Here we'll say Begin. We're going to install the piers and pier supports on day 7. We're going to install the pier top and diaphragms on day 14. On day 21, we'll install the temporary supports and drop segments. On day 28, we're going to add splices and remove the temporary supports and stress. On day 35, we're going to add the deck, and we're also going to add the barrier load. We'll save the model. If we go to Event Manager, we can see that at each day, the solve and the output commands are contained. And also at day 0, we have apply self-weight from earlier in the model. So that's okay. And now we can begin to assign the different elements to each step. So we'll select Install Piers and Pier Supports on day 7. We want to select each pier. We're going to right-click and say Install at Step. Notice that the color changes once the element is installed. On day 14, we're going to select the pier tops, and we're going to install those. We also want to install the pier top diaphragms. Right-click and install, and we'll do the opposite side as well. We'll now move to day 21, where we're going to install the temporary supports and the drop segments. The first thing we'll do is we'll select the supports. To do this, because most of our supports are temporary supports, we're going to go to Select by Type, and we're going to select Point Support. We're going to hit Control, and we're going to turn off the supports at the base of the structure. The remainder of the supports are going to be temporary supports except for the abutments. But these supports will also be installed with the temporary supports. So we're going to right-click, we're going to say Install at Step, and now those supports have been installed. You can tell that by the color change. We're then going to select the segments that are also going to be installed. These will include the interior drop-in segment, the end blocks, and the exterior drop-in segments. Next, we're going to add the splices, we're going to remove the temporary supports, and we're going to stress the tendons. We'll select each splice, and go to day 28, and we're going to install at the step. Now we're going to select the temporary supports that need to be deinstalled. If I right-click and say Remove at Step, those supports will now be removed. You can tell by the support turning gray and becoming inactive. If I was to left-click on a support, you can see that it was installed at day 21 and uninstalled at day 28. This shows the history of the support in the construction staging. The next thing we'll do is we're going to stress the tendon. If we grab the tendon, right-click, and say Install, the tendon is now orange, meaning that it's active and has been stressed. At day 35, we're going to add the deck and also install the barrier load. The first thing we'll do is install the deck. If I select the deck, verify that this is the deck segment because we have a travel path in the same layer, so it's difficult to tell which is which in the model. We're going to right-click again and install that at the step. So now the deck has been installed. We can now view the line load by going to Select Set View Items. We're going to select the line load, right-click, and install that as well. Again, the color change of the line load signifies that it's been installed. It's also important to note that any segment, either horizontal or vertical, can be cast at a day as well. If we select a segment and right-click, we can cast at a certain step. This allows the aging process for the concrete to begin prior to installation. If we install a step without the cast command, the installation and casting begin at the same time. Now that the staging process has been completed, we can review the Event Manager. Selecting Event Manager, we can look at the different staging or days in the project, and we can look at the events. We can add events from the list in the middle, or we can also delete certain events from the list on the right. We also have the option to move events up and down to change the sequence or the order of construction. We'll select OK, and the next step is to mesh the structure. The structure can be meshed manually or automatically by the program. To mesh manually, we'll select an object, like a segment or pier, and we'll double-click. Here we can give a preferred cell size, and we can use this tool to mesh manually. We can also define sub-segments for non-uniform geometry. To mesh automatically, we'll go to Process, Create Mesh. We've set the suggested cell size to 5 feet, and we've also included composite analysis. We'll say OK, and the program will automatically mesh the structure. Once the mesh has been completed, we can begin the analysis process. If we go to Process, we need to generate two input datas, one for the basic input and one for the moving load input. We'll generate the basic first, select Yes, and the input data will be generated. We can then select Process again, and we can generate the moving load data. After each input file has been generated, this message will appear saying that it's been successful and also that it has been saved at this location. We'll say OK. The user can also review the input data and also edit the input data by selecting this option, going to either of the files. A text file will appear which is fully editable by the user. We can now begin the analysis process. We'll go to Process, select Execute, and the basic analysis will begin. This will include a validation of the input file moving into the analysis for both non-composite and composite. Once the basic analysis has been completed, we can go back to Process, and we can execute the moving load analysis as well. Again, the moving load input data will be validated, and the program will begin the analysis process. Included in this analysis is the generation of influence lines for each node in the structure. The influence lines are created for each travel path defined by the user, and they include the results for moment, shear, axial load, and deflection. Finally, the analysis process can be completed by selecting Process and executing the elongation for each tendon. Note that these three processes can be run individually. However, the execution of moving load needs to be preceded by the execution of the basic analysis. All three analyses have been completed, and we can begin to review the results. There are two options for reviewing results in ADAPT-ABI. The first option is to review results through text form. Here we can go to Reports and select either of these reports. We'll select the Geometry and Analysis results. A text file will appear which will include all of the results and input for both pre-construction and post-construction phases. We can also review results graphically by going to Process and View Results. In this module, we have the option to select any day in the pre-construction phase. Using this drop-down tool, we can select day 7, and we could sequentially go through the order of construction. Here we can see that the different elements added for each stage will appear. We can also review composite results by selecting this option. Turning this option on and off will toggle between non-composite and composite results. For each stage, we can review bending moments, shear forces, axial loads, pre-stressing, stress contours, and also torsion. We also have the ability to view deflections and camber. For day 28, we'll view bending moments as an example. Here we can display minimum and maximum values. We can also turn those off, and we can also display values for each node. As we scroll through the sequence, the moment diagram shifts for that particular stage. The user can also select an individual element in the structure to review results. We'll go ahead and turn the moment diagram off, and we'll zoom in to the interior span. We'll also turn the tendon display off as well. We can select any individual element, and here we can review the frame element properties. To display the results, we can select any action. We'll select bending moment again, and the bending diagram along that element will appear. We can review results. With that moment diagram turned on, we can again select the element, and the results on the entity will appear. This is frame element 116 with the applicable results. The same actions and results can be viewed for the post-construction phase. Using the yellow arrow, we'll select post-construction. Several load cases and combinations are populated in the box to the right. Base load includes all loading except for pre-stressing and long-term effects. PT includes pre-stressing. PT hyperstatic is the hyperstatic effect or secondary moments and shears. LT represents the long term. Dead represents dead load minus the post-tensioning and also long-term effects. Current includes the base load plus the PT and long term. It would also represent the last day in the sequencing in the pre-construction phase. If we continue to scroll down, we also have the moving load cases that were generated by the user, case 1 and case 2, also the two combinations, including the envelope, and the program-generated moving envelope, which is the envelope for both of the moving load cases. We can select any of these cases or combinations. We'll select case 2, and again, any of the different results can be viewed on screen. We can toggle the composite for each of these cases or combinations. The user also has the option to create influence lines at any given node along the deck. With the module in post-construction phase, you can select the travel path, the action you want to display. Here we'll select bending moment, and we can also select the node that we want the influence line displayed at. We'll select node 5, say OK, and the influence line for the bending moment will be generated. These can also be generated for shear, axial load, and deflection. For additional information about ABI 2009, please view our website at www.adaptsoft.com.